All right, this is handout S2E, Shape Identification, Perimeter, and Area. So this is kind of a review from an earlier section from S2. And what we need to do here is to figure out the area that's shaded. And in order to figure out the area that's shaded, I need to figure out the area of this wedge of the circle. So imagine it's like a slice of pizza, right? We've got this area of the wedge of the circle minus the area of this triangle ACB. So we've got the wedge of the pizza minus this triangle, and that's going to give me this shaded region here. So if we use our formulas from our worksheet, the area of a sector, which is the wedge of the pizza, is the angle over 360 times pi r squared. So the angle over 360 times pi r squared, we know the radius is 4 centimeters squared. Our angle is 55. So here is the area of the pizza. And now we need the area of the triangle. And we're going to do 1/2 AB sine C. So C is the angle between the two sides we know. And since this is a circle, we know that A and B have to be 4. There's our A and our B. So we've got 1/2 4 times 4 times sine 55, which is the angle between the two sides. And we end up with this value. Subtract those together, and that gets you the area. This looks like a very tiny area, but it should make sense because it's a very tiny shaded space. Okay, hit pause to copy this if you need to. So when I look at these shapes, you should have discussed that they all have the same shape on the top and the bottom. And the only one that's different is the one that has is shape E, which is not a polyhedra. This is a cylinder, but it has similar properties to the rest of them. It just doesn't have any straight lines on the bottom. Okay. So in order to be a prism, it has to have a base which has the same shape on both ends of the base. Okay. And now we're going to talk about cones and pyramids. So all of these shapes here have a base, either rectangular or some sort of shape, and then they all come to a single point on the other ends, and the sides of all of these are triangular faces. Okay, except for the cone, which has kind of a curved face. Okay, so the top of a cone is called an apex, and like I said, the triangular sides is called a triangular face, and the height of how high the cone goes is necessary for what we're going to be doing in future assignments. Okay, and the side of the cone here is called the slant height, which is not to be confused with the height of the cone, which we just simply call the height. The tip of the cone is called the vertex, and the radius of the circular base is the radius. Okay? So, we need to remember the circumference around, the length around a circle is 2 pi r. You could also think of it as pi times the diameter, since the diameter is twice the radius. So find the three significant figures of the perimeter. So first off, this is half of a circle. So we've got our circumference, but we've also multiplied it times a half. So we've multiplied it times a half because there's only half of a circle. And then we've got 3 sides. So we've got the 4.2 plus 4.2 plus 10.8. Add those all together, and we end up with the area all the way around this shape is 36.2. Okay, next one. So this is half of a circle. So we've got pi times the diameter, which is 3.1. And then 1/2 of that gives me half of a circle. And then we add this line here, the 3.1, and adding all of the blue side plus the pink gives me the total perimeter. Okay, I've got 3 sides with length 9.7, and we've got half of a circle. Okay, now we have a whole circle here. Okay, and then we've got the length of 128 meters that we're adding there. Okay, the bottom here gave you all the formulas you need for the various shapes we're going to be working with. Okay. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So base 1 is 3x plus 4. Base 2 is 2x minus 1. And we add those together, and divide by 2, and then we end up with, and then multiply by our height of value of x, and that gives us our area of the trapezoid. Area of a triangle, 1/2 base times height. Our base is 3x, our height is x plus 1, multiply those together, there's our area of a triangle. Okay, next, base times height for the area of a parallelogram. Our base is y plus 2, and our height is y, and here we've got the area of a circle is pi r squared, but this is half of a circle, so we've got pi r squared, so pi times 2x in parentheses squared, and then divided by 2 since it's half of a circle, and we end up with 2 pi r x squared. Okay, calculate the shaded area. So we have the area of this rectangle and the area of this triangle. So the area of a rectangle is 3.2 times 5.3, and then the area of the triangle, so I needed to figure out the distance from here to here. So I did 8.6 minus 5.3 to get 3.3 for this distance here, and the distance here is 3.2, so area of a triangle is 1/2 base times height, so 1/2 3.2 times 3.3, and this gives me the area of the triangle. Add them together, and that gets me the area of the triangle plus the rectangle. Okay, area total is equal to the area of the rectangle minus the area of the circle inside. So area of the rectangle, 7.8 times 4.5. Area of the circle is pi r squared. Now the radius is not 2.1, the radius is 1.5. So it's going to be pi times 1.05 squared, and then subtract those, and this gets me the area of the shaded part. You may want to hit pause to copy this down. Next, okay, we have to figure out the area of the rectangle minus the area of the triangle. Here we figure out the area of the rectangle minus the area of the circle. Here I found the area of the large rectangle, which is 1/2 16 times 15, minus the area of the small triangle, which is 8 times 7.5. You may want to hit pause. Okay. Next, the rectangular lawn, 12 meters by 8 meters, a 3.2 square garden bed is dug out of it. The remaining lawn is reseeded and boxed. Each box costs $8.50 and covers 18 meters squared. First, find the area of the lawn. So the area is the area of the rectangle minus the area of the square. Area of the rectangle is 12 times 8. Area of the square is 3.2 times 3.2. Subtract them. That gets me the area excluding the square. Okay, the box covers 18 meters squared. And we know this is our area. So we multiply. So notice this is meters squared, and one box is this. So I'm going to have to divide by 18 meters squared in order to make the meters squared cancel out in the top and the bottom. And then we end up with 4.76 something something. So we're going to need 5 boxes. Okay, how much is the total cost of the seed? Well, each box costs $8.50. So 5 times $8.50 is going to give me $42.50. Okay. A curved cylindrical tank has a diameter of 8 meters and a height of 6. Okay. It's got a non-porous lining of a circular base and curved walls. The lining of the base costs $3.20. On the sides, it costs $4.50. So find the base radius. So if the diameter is 8, the radius is going to be 4. Okay, question B. Find the cost of the lining of the base. So the base is the circle on the bottom. So the circle on the bottom is pi r squared. So pi times 4 squared gives me 16 pi, or 50.3 meters squared. Okay, the cost of the base. So I take that area and I multiply it by 3.2, which is going to give me $161. Okay. Question D. Explain why the curved area of the wall is 2 pi r h. Okay, so if the curved area of the wall, if I unravel it, the distance all the way, if I unravel it, the distance all the way around is 2 pi r, because that's the circumference around a circle. And then the height is the height of the cylinder. So the curved wall base has a length equal to the circumference of the base, 2 pi r. And when it's unraveled, it makes a rectangle with a height of h. You may want to hit pause to look at this some more. Question E. So the area of the curved wall is 2 pi, and the r is 4, and our height is 6. So then we end up with this area. Our cost of the curved wall, it's $4.50 per meter squared. Multiply those together. Here is our cost. To figure out the total cost of everything, we're going to add the cost of the base plus the cost of the wall, and we get our total cost of $841, and that is only if it doesn't have a top. If our cylinder does have a top, which, a top and a bottom, we add an additional $161, because that is the area of having a top and a bottom. So this is the cost if there is a top and a bottom of our cylindrical tanks, and this is the cost if our cylinder tank only has a bottom and it's open to the air.